Okay, so that we start off simple and easy. What's the common base here?
3.
3. So we leave the 3 alone. And then subtract your exponents. 8 minus 2 is 6. And that's it, folks. Okay, so what do we have right here? What are negative 3 and 15?
Negative 1/5. Negative 1/5.
Good. Okay, they're coefficients, and we reduce coefficients, or divide. Negative 3 over 15 is negative 1/5. Okay. X to the 7th and x to the 3rd. 7 minus 3 is 4. Okay. So notice on this one, there are more x's in the numerator than in the denominator. There's 7 here and 3 here. So you keep your x in the numerator. Hold on. There are more 3's in the numerator than the denominator. So the 3 stays on the top of the fraction bar. Okay, it's going to change when we get to number 3. Yes, ma'am?
You don't put an x on the denominator?
No. Okay, so good question. So let me break this down really quick. X to the 7th over x to the 3rd really means this. Okay, x times x, okay, times x times itself. 7 times. Over x times x times x, right? That's the expanded. Like we did, remember yesterday we did expanded? Well then, these cancel. So how many are left? 4, and they're in the numerator. So that's why we keep it on top. Okay, does that help? That's where the whole rule for subtraction comes from, is this expanding and canceling. Okay? I'm going to show you. Good question. All right, so a to the 5th, b to the 9th, and then we have a parenthesis going on down here. So we're going to want to deal with this part first, right? Yeah. So what goes in the denominator right now? Okay, A4, B4. Okay, this one's going to be easy because, yeah, but how many, is it in the top or bottom? Top. I have more in the top. And b to the 9th over b to the 4th, that would be b to the 5th. And that's it. Okay, this is where it gets becomes different because you have more x's in the denominator than in the numerator. So really, this means x times x over x times x times x times x times x, right? So when you cancel, you still have 3 x's, but where are they? They're in the denominator. So you can still do 5 minus 2 and say 3, but you have to remember that when you write your answer, it's in the denominator. Because how I remember is that there are more x's in the denominator than in the numerator. So you keep your x's down low. Okay, does that make sense? Any questions on that? All right. 15, we have some coefficients. 15 over 5 is just what? 3 over 1, or just 3. I'm writing a fraction bar because I don't know what I'm going to be doing. Okay, a to the 4th over a. Well, how many a's is just a? 1. Okay, so that means 4 minus 1. 3. And that stays in the top. Okay. Uh-oh, I have b up here. B the first. And then I had b to the negative 4. Okay, 2 different things you can do. Move it up, because that's what we learned day 1, right? So you would have b to the positive 4th. Or you could literally do 1 minus negative 4 is 1 minus negative 4, y'all. 5. 5! Now you're going to hear me yelling at you on YouTube. 5. Because how many are up here? 5. B the first and b to the 4th is b to the 5th. Okay? So it seemed like a lot of you understood moving this to the numerator. because that's what we did day 1. So really you have b to the 4th on top, which together just means b to the 5th. And then again you have a c, but it's a -3, so what are you going to do with it? Move it to the denominator where there's already a c down there. So now we have a c cubed, and then we're bringing another c cubed down. So c cubed times c cubed is c to the 6th. Again, follow your rules and you'll be good. Okay, any questions so far? Let's see what time we get out of here. 45? 25. Okay, so we got to kind of move quickly. Okay. All right, here is scientific notation, right? In the year 2000, the United States public debt was about 5.6 times 10 to the 12th dollars. Woo! That's a lot, okay? The population of the United States in that year was about 2.8 times 10 to the 8 people. So what was the average debt per person? So what this is saying is, if we, the people of the United States, in order to form a more perfect union, decided that we were going to pay off the national debt as individuals, we would take the debt, divide by how many people there are, and that's how much each person, man, woman, child, baby, would owe in order to pay off the debt. So let's see how much it would be. But this is in the year 2000. Do you think that number has gone up or down? Okay. All right, so let's try this. So we take our debt, and divide it by the people. All right. So treat these numbers as coefficients, kind of like we did on the problems we went over in our homework. 5.6 divided by 2.8. Let's do that. 2? That's nice and easy. And then times 10 to the, and then treat these like regular, like common bases are 10. So what are we going to do with the exponents? Subtract. 12 minus 8 is? Okay. But how much money is that really? 2 times 10 to the 4th. So that means 2, and then add 4 decimal places. 1, 2, 3, 4. Put your zeros in there. Cha-ching. So how much does each person owe? $20,000 per person in order to pay off the debt of our country in the year 2000. Not per family, per person. What? Am I going to pay that? All right, so the volume of a cube is 125 x cubed y cubed cubic units. And the area of its base is 25 x squared y squared square units. What is the length of the edge of the cube in units if x has to be greater than 0 and y has to be greater than 0? Obviously, in lengths, you can't have anything less than 0. So we're going to take the volume and do what? What is the formula for volume of a cube? Length times width times height. Or side times side times side. Here's the cool thing, though. We already know the area of the base, which is the length times the width. We already know both of those numbers. So how are we going to find the height if we know that the volume is 125 x cubed y squared, x cubed y squared is equal to length times width is the area, 25x squared y squared, and we're still trying to find the height. You're going to divide by... Sorry, did I write it down wrong? Oh, thank you. This is a cubed. Cube. So 25x squared y squared. So this is just a division problem. It's not a hard problem. It's just division. So what is 125 divided by 25? 5. Awesome. What is x cubed divided by x squared? X to the first or just x? What is y cubed divided by y squared?
Y.
Y. So that's our height of our cube.
That's it?
That's it.
Is that going to come in a homework question?
Probably.
Then how are we going to know the area, the equation?
This?
Yes.
Because you've been doing it since you were little. Length times width times height. You know that one. I'm not going to like bust out like a cylinder or something. Or a cone. I'll keep it simple. Plus it's on your formula chart. Anyways, moving on. Okay, simplify the expression. So the first thing we're going to have to do is distribute these exponents. So 2 to the 3rd, x to the 9th, over y to the 3rd, z to the 3rd, and then from there you can simplify. But look, there's really not much we can do, is there? The only thing we can simplify is the 2 to the 3rd. Because there's no common bases, are they? This is an x, a y, a z. Nothing else we can do. Okay, what is 2 to the 3rd? So really, this is 8x to the 9th over y to the 3rd, z to the 3rd. But we can't simplify that anymore because there are no common bases. Okay, try number 9 on your own. Okay, so yeah, there is not much we can do in this situation except for distribute our exponent because we don't have any common bases. A to the 5th, b to the 20th, over c to the 10th, d to the 15th. Can we simplify it from there? Nope, we're done. Okay, what do we do when we have a negative exponent that's outside? No, you can't just randomly change it. Okay, 2 different things you can do. You can flip now, or you can distribute, then flip. Yeah. Once you do this, though, then... yeah. This goes down because it's negative, and this comes up because it's negative. Or you could have just flipped from the beginning. You could have done this. Notice how I did the reciprocal? And then now I can distribute. Either way works. And then you can simplify from there if you want. Okay. Okay. Again, do you like to distribute first, then flip, or flip first, then distribute? Flip first? Okay. So let's flip first. Y to the 3rd over 3x. So now it becomes a positive 2, now that I have taken the reciprocal. So what is my numerator now? Y to the 6, over 3 squared, which is really what? 9x squared. And there's nothing else we can do. Okay, I want you to try number 12 on your own. Let's see how we did on this one. So, did you flip first or distribute first? Okay, doesn't matter. But we can take the reciprocal first. And then it becomes a positive 2. So then we're going to distribute our exponents. A to the 6th, b squared over 2 squared, which is 4, a squared, b to the 12th. But now we do have some things to simplify. A to the 6th over a squared. There's more a's in the numerator than the denominator. So 6 minus 2. And it's in the numerator. We leave our coefficient at the bottom, just FYI. There's nothing else, no other coefficients. And then we have b squared and b to the 12th. So 12 minus 2, 10, but where does that go? Denominator, because there are more exponents down there. There we go. All right. Couple more. These are multiple choice questions. Which expression is equivalent to 27x to the negative 2y to the 6 over 3 to 5 to blah, 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 blah. Okay. What do we do? What are you going to do first? Simplify. Coefficients, 27 over 3. 9. So that's going to go in the numerator. So, bam, which one can we cancel?
B.
B. Okay. Then let's deal with the x's. We have x to the 5th in the denominator. And then we also have x to the negative 2 in the numerator. But what do we do to that? Bring it down. So really we have x to the 7th in the denominator. Okay. Bam. Okay. So we're down to C and D right now. Okay, y to the 6 over y squared. They're both positive, so you just subtract. 6 minus 2 is 4, and that's in the numerator because there's more y's up top. Z to the 0, 1. So it's not Z. So what is our answer?
C.
C. It's not D because of that Z right there. Okay, good. Emma was asked to find an expression that is not equivalent to 3 to the 4th. Which of the following is not equivalent to that? 3 over 10, 3 to the 10th divided by 3 to the 6. What is that equivalent to? 3 to the 4th. So that is not our answer. 1 over 3 to the negative 4, which is equivalent to, yeah, you bring this to the numerator because it's a negative exponent. So it's not B. Switch these, right, because they're both negatives. Then simplify. So it's not C, so hopefully it's D. Okay? Flip it. So it's 1 over 3 to the 4th. Okay, we're going to go ahead and stop there so I can hand out your homework to you guys.